video of me explaining the notes. So here we go. I just had a very large dinner, so I'm kind of tired, but we'll see how this goes. Okay, so here, 2.1.3, graphing quadratic functions. So I'm going to do this one and this one here. And then based on what I talk about, you should be able to answer this one and this one. And then your homework is attached here as well. Okay, so watch the video for this one and this one. I'll attach the key for this one and this one, and then your homework I want you to do in class. Feel free to work together, okay? So here, we're going to do all this with graphing calculators for right now. Okay, so what are the zeros? Find algebraically, are they real or imaginary? This you don't need a calculator for. So to find zeros, we set the function equal to 0, okay? This is already factored. It's already in factored form, so I don't need to reverse FOIL here. I just set these factors equal to 0 and solve. Okay, so here, if I have x minus 2 equals 0, I should get x equals 2. And then x minus 5 equals 0, and I should get x equals 5. Okay, so those are my two zeros. Zeros are the same thing as x-intercepts. Okay, so when I think of zeros, I'm really thinking x-intercepts on my graph. So I can plot those right away. Okay, so at x equals 2, I have this point right here. And then at x equals 5, I have that point right there. Okay. Now, a word we probably haven't talked about yet. So each zero is considered to have a multiplicity of 1 because we get each solution once when we solve. Only real zeros have multiplicities. Okay, so here, in my function, I have x minus 2 and x minus 5. So I have each factor once. So I get each solution once. That means that they have a multiplicity of 1. Okay, so I would just do m1 here, and this would be an m1 here. Okay, so that just, we're going to talk about it a little bit more in the future, but it kind of describes kind of what the graph looks like at those points. Okay. So now we need our graphing calculator. Okay, so find and plot the vertex. Use your graphing calculator to find. So I'm going to punch that into y equals like this. I'm going to zoom standard it, zoom 6, so I get a graph that looks like this. And now my vertex is a minimum point. Okay, so I'm going to go to second trace and then minimum, which is 3. And now it's asking for left bound. So I use my cursor to go anywhere to the left of my vertex. So it could be any point over here. I'll choose that point. So I press enter. And now it's asking for a right bound. I'm going to go anywhere to the right of my vertex. Could be there, could be there, could be there. It doesn't matter as long as it's to the right. I press enter. I don't want to guess, so I press enter. And then my minimum is 3.5 and negative 2.25. So that's my x and my y. So I'm going to write that down, 3.5 and negative 2.25. Okay. And this is slowing down here. This is a major bummer, negative 2. Come on, 0.25. Okay. So that's going to be 3.5, 1, 2, and a little bit more than 2. So right there. Okay. And now I should plot a couple more additional points to sketch it correctly. So here, plot at least 2 points on either side of the vertex. So I already have 1. I just need to plot one more. So it looks like at 3 I can plot a point, and then at 4 I can plot a point. So let me set that up here. I have 3, comma, and then I have 4, comma. Okay. So if I go to second calc value, I can punch in 3, and I get negative 2. And then I can also punch in 4, and I get negative 2. Okay, so those are my 2 additional points. And again, you really could do anything. So I could have done, hold on one second. I could have done like 1 and 6 or whatever. As long as I have 2 points on either side, I'm pretty good. The closer, the better. That's why I chose those 2 points, but it really could be anything. So I have a point there, and I have a point there, And then from here, I'm able to sketch the graph. This is not going to come up because my computer is freezing. Kind of like that. And then kind of like that. Hopefully it went through. Oh boy, this is not good. Holy moly. Yeah, you get the gist. Okay, so a frozen computer is not very beneficial, but I should obviously connect those 2 points and then make a parabola out of it. Okay, so I'll fix that on the actual notes, but should look something like that. Okay. So let's look at another one. Okay, so here I have x plus 1 times x plus 1. I'm going to close this for a second so it speeds up, hopefully. So here, a big question, how can I rewrite f of x? So you should notice that I'm multiplying these two factors together. So I can rewrite this as f of x, there we go, it's already faster, equals x plus 1 squared. Okay. Now, what are my zeros? Okay, same idea as above. I set the function equal to 0. And then I solve, and you'll notice that I get the same solution. So no matter what I do, plug these in down here, I should get x plus 1 equals 0. And then x equals negative 1. So I only get 1 0 here, and I get it twice. Okay, so that's describing the multiplicity. A 0 is considered to have a multiplicity of 2, because we get the solution twice when we solve. What does the graph do at the 0 in this example? We'll talk about that in a couple seconds. Okay, so because I get this solution twice, I have two factors there. I can say this has a multiplicity of 2. Okay, so most of the time you're going to see it like this. I have x plus 1 squared. That means that I have 2 of those factors together, so it's a multiplicity of 2. Okay, so now from here, I'm going to open this back up, unfortunately. So with x plus 1 times x plus 1, I'm going to punch that into y equals. Okay. So y equals parentheses x plus 1 times x plus 1. And when I zoom standard it, which it already should be in, but I'll do that anyways, I'll get a graph that looks like this. Okay. So looking at what we have, okay, so this is an x-intercept, so I do know that I have a point right here. Okay. And then my vertex, if I look at my graph, my vertex is that point. So that's the midpoint. So I already have my vertex. That vertex is at negative 1, 0. Okay, so when I want to plot 2 points on either side, I'm going to need 2 more points on either side, so 4 points total. So I have my vertex at negative 1. I'm going to plot a point at 0 and 1, and then negative 2 and negative 3. So let me set those up. 0, 1, negative 2, and negative 3. Okay, so here I have a bunch of points. I'm going to use my table feature to check these out. Okay, so hopefully we're in the right mode. Second table set, go to ask mode, not auto mode. And now I can punch in what I want. So I can plug in 0. I can plug in 1. I can plug in negative 2. And I can plug in negative 3. So I have 1, 4, and 1, 4. Easy peasy. Oops. Okay, so this gives me 1, this gives me 4, this gives me 1, and this gives me 4. Okay, so my points should look a little bit something like so. And I'm not going to sketch this because it's going to get all messed up. But again, you should connect the points and then make a parabola out of it. Okay. So before I finish, this kind of explains everything about multiplicities. Okay, so if it has a multiplicity of 1, at those zeros, it goes through normally. So it goes through normally there, goes through normally there. There's no change in the shape of the graph at those points. If there's ever a multiplicity of 2, it's always going to do this. So it's not going to go through, it's going to hit the x-axis and then come back the same direction. So if it's coming from above, it hits and goes back up. If it's coming from below, it hits and then goes back down. So that's always the behavior if it's a multiplicity of 2. Okay? So with that in mind, I want you and your neighbors to, again, try this one, give it a shot. Try this one, give it a shot. I'm going to put the key to these in Schoology, so make sure you take a peek at that. And then your classwork/homework is here. Okay? All right. Have fun. Be good. Bye-bye.